So as of right now, we have three methods to factor. We have factor by GCF, we have factor by grouping, and now we have the easy types, right? So easy type, x squared plus 7x, how about minus 30? What would I be looking for here? Two numbers that do what? Multiply to 30. Careful. Subtract to 7. So what are two numbers that multiply to 30 and subtract to 7? 10 and 3. This sign tells me my signs have to be different because you got to multiply to a negative, so I need one positive, one negative. The bigger one has to be positive. So the 10 would be the positive, 3 would be the negative. Yes? Today, we're doing what I call the fun type. I'm not calling them the hard type because they're not that hard. There's just more to them. Okay? So the problems we're doing today, the reason we call them the fun type is there's just more to them. So, and the reason there's more to them is what's different about this problem than what we did yesterday? There's a coefficient on that first term, right? The x squared. Okay. That changes a lot. And by putting a number other than 1 here, that actually changes everything that we have to do here. And the reason that is let's just take a number, let's just take a binomial like 3x minus 2 times 4x plus 5. Let's take I got to FOIL that. What's 3x times 4x? 12x squared, right? And then 3x times 5x would be 15x. The negative 2 times the 4 would be negative 8x. And negative 2 times 5 would be negative 10. So this actually simplifies to, that'd be a positive 7x minus 2, or minus 10. So the question, again, we're doing the same thing we did yesterday, just with these types of problems. So we're going to start here, and we got to end up here. Where does the 12x come from? Where does the 12x squared come from? Where does this one come from? It came from the 3x times the 4x, right? So we got that from 3x times 4x. Okay. Where did the 7x come from? Where did this part come from? It came from the 15x minus the 8x, right? But where did the 15x come from? It came from the 3x times the 5x. So it's like the outside two numbers multiplied together, right? And where did the negative 8x come from? The negative 2 and the 4, right here, the insides. So this middle term is always going to be the outsides and the insides, right? The 12x squared came from the 3x and the 4x, which was the f. That's the first terms, right? The negative 10 is going to come from the negative 2 and the 5, which was our last terms. So what's different here is when we start here, we're going to have, we got to find ways to get to this 12. Well, there's lots of different ways to multiply to 12. And then we got to multiply together to get 10. Well, there's different ways to get a 10. And then we got to figure out how we get to our 7. So these problems, you can just imagine right now, there's a lot more possibilities to run through our head here. Now, here's how we're actually going to solve this. When you do these, there's no other really good way than simply just to list all these ways. What you're going to do is you're going to say, list all the different ways to get to a 2. How do you multiply together to get a 2? 2 times 1. Okay? How do you multiply together to get a 12? So I like to put them in order. 1 and 12. And actually, and then you got 2 and 6, right? And 3 and 4. Now, it doesn't matter which list, but one of the 2 lists you have to list in both orders. So you got to list it both ways. You go 1 and 12, 12 and 1, because it could be either or. Okay? Now, if I list this method or this list both ways, I don't have to list this one both ways. If I list this method or this list both ways, I don't have to do that one. So it doesn't really matter which one. So I know right now, because there's only one listed over here, I know my answer. I know my first terms. This list here is going to give me my first coefficients. So this 2 is going to go right there, and that 1 is going to go right there. I know that. That has to go there. Okay? Now, these numbers are going to be what give us our second numbers, but we don't know which combination works. For this problem, what we have to do is we have to check outsides together and insides together. And that's how we're going to add to get to the 11. So what we're going to do is we're going to take this list right here with each one of these possibilities, and we're going to check outsides together and insides together. What is 2 times 12? 24. What's 1 times 1? Can I add to 11 with a 24 and a 1? No. So that is not the correct combination. So now I go to the next one. And I say, all right, how about this one? Outsides together would give me a 2. Insides together would give me a 12, because we're multiplying, right? Can I make an 11 out of a 2 and a 12? No, that'd be 14, right? Great, so we know these two are not the possibilities. Now we check the next one. Outsides together would give me 12. Insides would give me 2. Does that work? Nope. Now we check the next one. Outsides give me 4, 6. Does 4 and 6 get to 11? No. So we check the next one. Outsides give me 8. Insides give me 3. Does that add to 11? 8 and 3. Oh, so we've found our magic combination. It really is just going to be guessing and checking of which combination gives us that magic combination. Now, the answer is you have to pull these numbers in exactly that order. The 2 and the 1 have to go 2 and the 1. The 3 and the 4 have to go 3 and 4. They have to be exactly in the order that you wrote them. Then the signs are going to be the same as we did yesterday. What does this sign mean? They have to be the same, right? You can't, if this is a positive, they have to be the same. If they're the same, then they're both positive. So that would be our answer. There's a lot more to these today because there's a lot more possibilities. There's a lot more combinations that these could be. So let's try another one. Let's say 6x squared plus 17x plus 5. Okay? The first thing you got to do, first thing I would do for all of these, can you pull out anything out of these? Can I do like greatest common factor factoring? Because if I could pull that 6 out, that would make my life a lot easier. I could then go to the easy type. But here, there's nothing I can pull out, right? So the next step is list. What are all the different combinations that multiply together to get a 6? 1 and 6, 2 and 3, right? Okay. What are all the different combinations to get to a 5? 1 and 5. Now again, one of the two lists, it does not matter which one. If I list it 1 and 5, I also have to go 5 and 1. This one actually there's only 4 combinations to check. But what am I looking for? I'm looking for outsides and insides that add up to, because this tells me to add or subtract, to 17. So I'm looking to add to 17. Outsides give me 5, insides 6. Can 5 and 6 add to 17? No, so it's not those top two. So let's try this one. Outsides give me 1 and 1 makes 1. Insides give me 30. Does 1 and 30 add to 17? So I know what just happened. That was freaky. What in the world was that about? Okay. I don't know what happened. Okay, so we know that 1 and 6 is out, right? So it has to be this one. So now I check this one with both of those. Outsides would give me what? 10. Insides give me 3. 10 and 3 do not add up to 17. So that one's out. And we check this one. Outsides give me 2. Insides 15. Does that add up to 17? Yes. So there's my magic combo. So that tells me my answer. These two numbers have to be the first two numbers. So this would be a 2x. This would be a 3x. These two numbers are the ones that go with the x because they got to go to this 6x squared. These two numbers are our last numbers. So this would have to be a 5. This would have to be a 1. And they have to go in that order. 2, 3, 5, 1. My signs have to be the same. They're both positive. Now again, how could I check my answer? You could just FOIL it out and double check your answer. Everybody take out a sheet of paper. Come on guys, Abby, Cam. With these, this one wasn't too bad. Why was this one not too bad? There's only four possibilities. Sometimes there's going to be only a few combinations. Sometimes there's going to be a lot. Sometimes even if there's a lot, you might find the magic combination as one of your first ones. Or it might be one of the last ones you check. Like this one, it was actually, out of the 4, it was the last one we checked, right? It really is just almost a guessing game as of which ones is it going to be first. So everybody write this one down. So we got 9x squared minus 15x plus 4. What is the first thing we have to do here? List. What are all the different ways I can get to a 9? 9 and 1. And it doesn't matter if you write 9 and 1 or 1 and 9. 3 and 3. Now, if I write that one backwards, is that ever going to matter? No. Okay. How about 4? 1 and 4. And I would also write 4 and 1. And then 2 and 2. Do I have to write that one backwards? No. So we've got 6 combinations to check. And is there anything that says I have to check them in order? If I want to, I might think, hey, 3 and 3 and 2 and 2, that's probably the right answer, right? Because everybody, it's most likely they're not going to pick 9 and 1. They're probably going to do 3 and 3 here. You can check in any order you want to, whatever you think the answer is going to be. But what are we looking for? These answers have to do what? Add up to 15. So we're looking to add to 15 here. So where do you want to start checking? You want to do the 9 and 1 first or the 3 and 3 first? 3 and 3? Great. Let's start at the bottom, work our way up. Outsides would give me 6. Insides give me 6. That does not add up to 15. Outsides would be 3. Insides would be 12. Does 3 and 12 add up to 15? Yes. We've got our combo. I don't have to check anymore. So I actually found it on the second try here because we decided to start it with the 3 and 3. You don't have to start them in order. Does everybody see how this is the magic combo? And actually, either one of these would work because 3 and 3 is the same thing. But what does that mean about my answer? Where do the 3's go? This would have to be a 3x. This is going to be a 3x. What number goes here? 4, 1. My signs have to be the same. They're both negative. You are done. Why are these worse than the ones we did yesterday? The reason is the ones we did yesterday, like these that I call the easy type, x squared, let's do plus 5x, oh, stupid thing, 5x plus 6. You really are doing the same thing, but here's the key. This is a 1. What are all the different ways to get to a 1? 1 and 1. What are all the different ways to get to a 6? That's what we're going through in our head, is we're going 1 and 6, 2 and 3, right? Do we have to go outsides and insides? Why not? Because you're timesing by 1. It doesn't really matter, right? So in all reality, we're just looking at this list going, which ones add up to 5? It's that 2 and 3. If you wanted, you could say 1x and 1x. And then the 2 and the 3. My signs are the same. They're both positive. What makes these easier? You don't have to do that list because it's 1 and 1. So you're only looking at one list. With these problems, we have no choice. There isn't a better way to do these. We have to look at what are all the different ways to get to this. What are all the different ways to get to a 4? Then we have to check outsides together and insides together and see which combo adds up to 15. There's no other way to do these. Like, it's really just going to be guessing and checking, and you got to check your way through all of those. Let's try. How about 4y squared plus 7y minus 2? What's the first step here? Make your lists. What are all the different ways to get to a 4? 4 and 1, 2 and 2. What are all the different ways to get to a 2? 2 and 1, and 1 and 2. I typically only write the second list twice, but what I'll also do is I'll look at which list is shorter, and I'll write the shorter list twice. That way I don't have, if I've got 5 different ways to get to a number, I don't want to write 5 more and have 10. So I might have 5 on this list, and then this one only has 2, so I'll write that one twice. Okay? So, what are we looking for now? Outsides and insides, but this time they have to subtract to get to a 7. So we're looking at how do you, so when we do outsides and insides, we're not adding those two numbers to 7, we're subtracting those two numbers to 7. So let's start here. Outsides give me 4, insides 2. 4 and 2 do not subtract to 7. How about this one? Outsides would give me 8 and 1. Do 8 and 1 subtract to 7? Yes. So there's my combo. So what's my answer? What goes here? 4x. What goes here? 1x. What goes here? 1 and 2. So we got all our numbers in place in the same order. 4 and 1, 1 and 2. This means my signs have to be different. The bigger number is positive. Now, when we do bigger number, you've got to think, what's the bigger number? The 8 or the 1? I want the 8 to be the positive number. I can't change that sign. So how do I make the 8 positive? I have to make the 2 the positive. I want this 1 to be the negative, so that means this one has to be the negative. When you say the bigger number, it's the bigger product. You got to multiply the numbers together to get that. Does that kind of make sense? Let's try another one. How about, oh, I like that one. Okay. If you ever run into something that looks like this, what about this problem looks kind of confusing? Which negative? Because I see 3 negatives. The first one. Honestly, we know how to deal with that being a negative, right? And we also know how to deal with that being a negative. But we don't know how to deal with that thing being a negative. If you ever run into a problem where this A value is negative, we never, ever, 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 ever want to try to factor with that being a negative. So the first thing we'd want to do is just simply pull out a negative 1. By dividing everything by negative 1, what's going to happen to this? It's going to turn into a positive 2. That's going to turn into a positive. And actually, this one's going to turn into a positive, right? So now, my answer, I'm just going to have that negative 1 out in front. Now I kind of ignore it, and I just kind of leave it out front. Now we factor this just like we did before. We make our list. What are all the different ways to get to a 2? 1 and 2. What are all the different ways to get to a 7? 1 and 7, 7 and 1. We're looking to add up to 15. Outsides give me 7. Insides give me 2. That doesn't work. Outsides give me 1. Insides give me 14. That works, doesn't it? So, what goes here? 1x, 2x. What goes here? 7 and 1. My signs have to be the same. They're both positive. So, no matter what, if this value is a negative, pull that out right away. We never want to factor with that being a negative. That creates a lot of problems for us. It's possible to do, but it creates a major, major problem for us. Okay? How are we feeling with these? I will tell you, the one and only way to get good at these is you have to practice them. Like, there's no other good way. It's not something that you can just kind of do 1 or 2 and see. You have to kind of try a bunch of these and go through them. And then you need to know your multiplication facts. The better you know your multiplication facts, the easier factoring is. If it's causing you problems to create these lists, that becomes a big problem. And that creates it just creates things where it's just hard to deal with, okay? All right, everybody take a look at page 552. 552. Let's try some of these. We'll start the first few together. Number 2 is the first one of your homework today. It says 5x squared plus 31. And sometimes it doesn't always work, but sometimes you can kind of predict. How are we going to get to 31? How am I going to get to this 31? Well, I don't have to worry about multiplying. Remember that we're going to add to this. We create our list. What are all the different ways to get to a 5? 5 and 1. What are all the different ways to get to a 6? 6 and 1, 1 and 6, 2 and 3, 3 and 2, right? But use your brain here a little bit. We got to get to 31.